All right, good morning. Welcome back. Hope you guys are all doing well, staying safe. I hope you had a good weekend. Looks like a nice day out today, but they're calling for some rain the next couple of days. So if you have a chance to get outside, enjoy it before it does rain and enjoy the day. Different routine today. I have a mixed class. There's some people in person, obviously, and obviously more people are at home. 21 people are actually, no, like actually 17 people are about home, and the remaining of the students are in class. So just a little heads up. 4, 6, 7 people are in school. Cool. If you plan to come back, there are 7 people in class, and we're pretty distant. I'm looking for a few people today, though, or actually just Nidal. Nidal, if you're here, please let me know. Nidal, if you're here, please let me know. Did anybody do anything fun over the weekend they want to share? Fine, I guess so. I'll share with you my little weekend. My weekend, my little guy had his first T-ball game, and it was on Saturday morning. If you remember Saturday morning, if you're out, it was freezing Saturday morning. It was 34 degrees, and we made it through a solid inning. T-ball, everybody bats, everybody plays the field. It was a good time, though. What's up here? There's my little guy. T-ball game, freezing out there. A little clear up there. There he goes. Still trying to figure out the basics of T-ball, so cold. Real cold out there. It was a good time. My highlight of the weekend. Hopefully you had a good weekend too. Does anybody have any questions for me before I begin today's class? Do a lot of this. This is what we do for fun. Early in the morning on nice mornings. Take them out like 6 o'clock in the morning and just push them on the swings. Best thing ever when the time's right. Brushing their teeth. We had donuts. That was a highlight too. Daylight donuts. Oh my. Donuts are huge. But they're pretty good. Let's see. What's going on here? All right, let's figure out what's happening for the best class of the day. Not before we do that, let's go to the COVID report. Thanks, Jumila. Appreciate it. Let's see what's going on for COVID in the county. So here we go. Here's Oneida County's dashboard for COVID. And right now there's 385 active cases of COVID in the county. Friday when I saw you guys, there's 390 active cases. Yeah, we went down 5 cases. Good. Right now there's 20,773 resolved cases of COVID and 419 deaths from complications to COVID. Yeah, that number increased by a couple from the weekend. So a couple more families, a couple more people passed away or impacted by COVID. Hopefully it wasn't yours. Hospitalization numbers, 13 people in the hospital. That went down a couple. And 5 people in ICU. Number of doses or vaccines. Oneida County adult population percent of the first dose above 16 years old. Right now in Oneida County, there's 52.8% of people in the county above 16 that had their first dose of vaccine. Maybe Pfizer, maybe Moderna, but they had their first shot. Hopefully in 2 weeks they get the full vaccination. And the fully vaccinated people in Oneida County over 16 are 43.6%. So that went up maybe 1% or 2% over the last 3 days. That's the key here. Once we get to like 60% population that's fully vaccinated, they've been talking about this number for a long time, 60% fully vaccinated, then things will really start to open up and you'll start to see these COVID numbers really starting to slow down or decrease in our county. Reminder, if you're above 16, you want to get vaccinated, you have the ability to check out the Oneida County website and you should have access to different pods, different locations where you can get vaccinated. Daily numbers for today, here we go. Not the lottery. The daily numbers of COVID cases. On May 1st, there's 24. The day before that, there's 43. The day before that, 36. The day before that, 48. So generally, the last few days of data, general trend is decreasing again. But you guys know we're all over the board. Up, downs, valleys, peaks, crests, troughs, all this. It's happening throughout our area. Can't really predict much anymore. Hopefully we stay below 50. So when I check out this COVID curve, which you guys know, I'm looking at that grid line right there. And hopefully everything's below that again. So as a scientist, you should be able to predict what's going to happen. When more and more people get vaccinated, these numbers should start to decrease. Maybe they're going to be inconsistent, but they should decrease. They should kind of mimic what's going on probably over here. More people get vaccinated, the more numbers will look like this. Hopefully that happens. Reminder, COVID is definitely in the area. Be smart, be safe, protect yourself, protect your loved ones. You don't want to get impacted with COVID. In school, we're smart, we're safe, we're wearing our mask, we have sanitizer, we have wipes. There's all the stuff that you could use to sanitize your desk, your Chromebook, your hands, whatever you want to do. Feel free to use it. All right, let's figure out what's happening for the best class of the day. Here we go. Today's Monday, March 3rd, 2021. Welcome back. Quote of the week comes from an unknown source. Chemistry states, the more energy put into a bond, the harder it is to break. The harder it is to break, not the break. The harder it is to break it. You get a boo and you put a lot of energy into it, it's going to be tough to break that bond. You put a lot of energy in the bond you have with mom, dad, grandma, your brother, sister, you bond with them, you care about them. It's tough to break that bond. Like that quote. Today's Monday, March 3rd, 2021. It's day 4. We are continuing on, and we will finish Unit 9, acid, bases, and salts this week. We definitely will cover that. We'll finish it this week. We're going through topic 4B, pH indicators today. Yes, I know a lot of you guys saw that pH indicators. There was an exit pass that was due Saturday. You know me. If I put it up there and you don't know how to do it, it's not really a sign. I put it up there anticipating it would be due this week or last week, but it's obviously going to be due when I go over it, after I go over it. That assignment for the exit pass and the examples will be due this Saturday. What's going to happen today, we're going to finish up YouTube video for pH scale. We'll go through some guided notes. We'll watch a flick on pH indicators, and then we'll figure out what the heck indicators are with examples and the exit pass. If we have more time in class today, we'll go through topic 5A, which is neutralization. We'll watch a YouTube flick on that. We'll go through some guided notes, examples, and the exit pass as well. That's the plan. If we don't get through it all today, we'll push it towards tomorrow. Whatever we don't get done, it's the next level for tomorrow, next step for tomorrow. And the attachments are below. You have the reference table and the 3 flicks that you can watch over and over and over again if you want to. Let's start off here. Let's do a quick little review. So we should know what a pH scale is by now. Maybe you took the weekend, maybe you drew a new version of a pH scale. It's not a bad idea. But on a pH scale, we should be aware of a couple things. We should know the values, 0 to 7 to 14. We should know the pH scale goes from 0 to 14. We should know 0 to 7 are the acids. We should know 7 to 14 are about the bases. So again, 0 to 7 are acids. 7 to 14 we should know are bases. We should know at 7 it's going to be neutral. Neutral. All right, those are neutral. We should know what makes an acid an acid. What makes an acid? It's going to have the H plus ions. We should know what makes a base a base. A base is going to qualify for having OH negative ions or hydroxide. OH negative or hydroxide ions. Hey, Nadal. Please try to get here a few minutes earlier next time. So OH negative is going to be a base, going to make it a base. We should also know at a neutral point, why is it neutral? The H plus is equal to the OH negative. What makes a strong acid? What makes a strong base? Stronger acids are going to be like a 0 or a 1. Maybe you redrew this again. Weaker acids are going to be like 5 or 6. They're closer. They're more neutral at that point. Same thing for bases. You should be aware of the zones, the location for strong and weak bases. What's a weak base? About 8 or 9. Strong acid's going to be about 13 or 14. What else do we know about the pH scale? We know hydronium hydroxide ions. At 0,1, there's going to be a high concentration of H+. There's a low concentration of OH negative. Hydroxide's low there. For strong and weak, strong bases, why is it strong? It's a high concentration of OH negative, and hydroxide is high there. H+ is going to be low. pH scale. We should understand that. We should understand what makes an acid, why it's an acid, why it's a base. You should understand the concentration of those as well. We went through some common examples. We went through the concentration and power of 10, but that's a pH scale. All right, let's watch a flick. Here we go. Let's analyze this flick. Then we'll get right to some notes here. On indicators, and figure out what an indicator is. What is a pH scale?
In this video, we're going to have a look at the pH scale and some other simple indicators of acids and alkalis. In other videos, we have seen what makes something acidic, neutral, or alkaline. We can tell if something is acidic, alkaline, or neutral by using an indicator. Indicators are substances that show different colours when they are in acidic or alkaline conditions. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus is red in acids and blue in alkalis. Litmus paper is made from lichens, which have been used to dye cloth for hundreds of years. It can be used as a liquid or paper. The paper is easier and more reliable. It comes as red litmus paper and blue litmus paper. Red litmus paper changes colour from red to blue under alkaline conditions, but no change under acidic conditions. Blue litmus paper changes colour from blue to red under acidic conditions, but no change under alkaline conditions. So just remember that red litmus paper changes colour for alkalis and blue litmus paper changes colour for acids. However, litmus paper only tells us whether something is acid or alkali, but it does not tell us how acidic or alkaline a substance is. For this, we have the pH scale and a universal indicator. Universal indicator is a mixture of different indicators, or dyes, which has many different colour changes, and so shows us the pH value of the solution. Again, it can be used as a liquid or a paper. The pH runs from 0 to 14, with 0 being extremely acidic, 7 being neutral, and 14 being extremely alkaline. Stomach acid is a strong acid with pH of about 2. Acid rain has a pH of about 5.5. Milk is neutral with a pH of 7. Seawater is a slightly alkaline. Soapy water is a strong alkaline. And bleach is a really strong alkaline with a pH of 13. Universal indicator is so called due to its ability to indicate the entire pH spectrum. There are other indicators that can be used that have other colour changes, but these two are the ones you need to know. We can also get even more accurate measurements of pH using a pH meter, which will give us readings to 0.01 of the pH. So from this lesson, you should now know indicators can tell us whether something is acidic or alkali and how acidic or alkali it is. Red litmus paper changes colour for alkalis and blue litmus paper changes colour for acids. And universal indicator can give us more detail, indicating where on the 0 to 14 pH scale a solution is. Acids are from 0 to 6, neutral is 7, and alkalis are 8 to 14.
All right, so indicators. There's different indicators that we will explore in today's class. Let's open up the reference table to start that off and figure out what and where we could locate indicators. So opening up the New York State Regents Chemistry reference table, there's a page devoted to acids and bases. On the reference table, we went through page 1, done. Page 2, we went through, we're done. Page 3, we did already, it's done. Page 4, we went through. Page 5, we went through. We went through metals, reactivity. We went through common reactions, heat of reactions. Next page, page 6, we went through common acids. We discovered common acids. We figured out what makes an acid is the H+. H is a positive charge, it's going to be an acid. We talked about common bases, what makes and qualifies for a base, it's hydroxide. If we scroll down, there's a portion on indicators, which is the main topic of today's class. Table M. It says right there, there's common acid base indicators. So we have methyl orange, there's a range in terms of color. There's bromothiamyl blue, there's a range in terms of color. Phenolphthalein, litmus, bromocressyl green, and thymol blue. So a quick little intro, what's going to happen with an indicator. Indicators are used to tell you what the pH level is going to be for a substance. I'll show you a demonstration tomorrow. We'll use a couple indicators and we'll figure out what the pH is going to be using one of them. Quick little reference again, we know the pH scale goes from 0 to 14. 7 is the neutral point. We know acids are up here. We know bases are 7 to 14. If we're using the first test, so if we have an unknown solution and we test it with some methyl orange, you're only using one test at a time, so you don't focus in on all these indicators. Methyl orange, how does it work out? Methyl orange, if the color turns red with methyl orange, you have a red color. If it turns red, the substance turns red, the pH is going to be 0 to 3.1. So pH turns red, the range is going to be 0 to 3.1. So 0 to 3.1 with methyl orange, it's going to turn red. We know the range with methyl orange is going to be 0 to 3.1. If the substance is orange, then it's going to turn, or the pH is going to be 3.1 to 4.4. So again, orange is going to be like the 2. The blend of red and yellow is orange. So 3.1 to 4.4, this substance would turn orange. If it turns yellow, what do we know? If it turns yellow, it's going to be 4.4 to 14. So 4.4, this whole span on the pH scale, if it turns yellow, it's going from 4.4 to 14. We know it's going to be somewhere within that window. I don't think it's that tricky to figure out. We'll analyze several examples on pH indicators. Actually, for today's lesson, there's this first topic, there's actually no notes. Let's analyze some examples in the Google Forms. We'll figure out how to use each one of these tests. We'll go through this slowly. You'll figure out the process. And then you'll figure out how indicators actually work. So let's try it out. No notes today. We're going right to the indicators. Please open up the exit pass. If you're in class, please open up the exit pass as well. And then we could go through the examples as well. Examples and exit pass we're going to need. So I know some of you guys already attempted it. Please open up examples for pH indicators. We'll figure out how to use this. pH indicators. All right, so we definitely need that portion of the reference table. You can use a hard copy, you can use a digital copy. I don't care what you use here. So let's practice this out. Here we go. Examples, Unit 9, Topic 4B, pH indicators. So by now we know about the theories for acids and bases. Arrhenius, Bronsellari, Lewis. We know about the pH scale. We did that. Now we're going to figure out how to determine the pH of an unknown solution. Question number 1. An aqueous solution turns litmus red. The pH of the solution could be what? So what do we have in this question? We have the indicator is going to be litmus. And litmus turns red. The pH of the solution could be what? So I'm on table M. Litmus is an indicator that we could use here. On table M, I'm just focusing on litmus. I don't care about anything else but litmus. So litmus paper, maybe you did this test in bio class before, but with litmus paper, if you dip the paper into an unknown solution, it's going to turn red or blue, or it might look purple. Red or blue. If the litmus turns red, there's a color change, the pH is going to be 0 to 4.5. If the paper turned blue, the pH is going to be, if it turns blue, it's going to be 8.3 or greater. So I think this is going to help you out quite a bit when I color code this. So 8.3 to 14, if it turns blue, it's going to tell you what's within that window. If the paper turns red, the pH is going to be 0 to 4.5. You can see that connection. We know for this one, if it turns red, the pH has to be from 0 to 4.5. There's not a value at 4.5 or below, but the closest one, this isn't the best question to start off with, the closest one's going to be 5. So the closest to red would be the smallest value. We know for a fact, if it's a pH of 14, 14 is definitely going to be blue. Not going to be there. pH of 11, definitely going to be a higher pH. It's going to be blue too. And 8.3 is on the edge, but it's still going to be closer to blue than it is red. Number one, the best answer is going to have to be choice D. One is D. Tricky one to start off with. One would be D. Let's try number 2. Litmus test again. In a solution, litmus is blue. The pH of the paper, the pH of the solution could be what? So again, I know some of you guys already know what to do. Again, just focus on litmus. I don't care about Rome Cressel green. I don't care about anything else but litmus. It says litmus paper, litmus test turns blue. There's litmus. We are turning blue. Blue. If it turns blue, it's going to be 8.3 and above. 8.3 and greater. So 8.3 to 14, it's going to be blue. Let's check out some points here. pH of 2. 2 is going to be over here on the pH scale. So each one of these is a pH scale. So each one of these ranges represents a whole pH scale. 2 to 4.5, it's going to be red. It's going to be an acid. No. 3, it's around there. It's an acid. 4, right there, it's an acid as well. pH of 10, you can see in the situation, pH of 10, it's in between that window right there. It's going to turn blue. It's going to be a base. So best answer here, base, is going to be choice A. So the pH test, these indicators, or the litmus test, is a quick reference to see if something's an acid or if something's a base. So litmus paper, you dip the paper in and it turns red. It's going to be 0 to 4.5. That's a quick little reference. It's probably going to be an acid. You dip the litmus paper in again and it turns blue. pH is going to be 8.3 to 14. So it's a pretty good test to see is something an acid or is something a base. Choice 2, or number 2, the best answer is choice A. I think you're getting the hang of it. Let's try another one. What solution can turn phenolphthalein pink? So phenolphthalein, cool word. We'll test this tomorrow as well. So phenolphthalein, find phenolphthalein on the reference table. It is an indicator as well. So just focus on phenolphthalein. Once you know how to do this, folks, you get it. Nothing different here. You know how to do one of these, you know how to do all of them. So you have phenolphthalein, it turns pink. So I picked this out of the passage. Phenolphthalein turns pink. There's phenolphthalein. It's turning pink. What do we know about the pH? The pH has to be 9 or above. So pH range goes from 9 to 14. Thing I would ask next is 9 to 14. Is that an acid or is that a base? So 9 to 14, is that an acid or a base? Anybody know? Yeah, it's going to be a base. So that's definitely going to be a base. If it turns pink, it's going to be a base. If it was clear, it's probably going to be an acid. It turned pink. We are looking for something that's pink. It's going to be a base. We are looking for something up here that is going to be a base. Which one of these up above are a base? Let's go through it. Maybe you know. Maybe you're stuck. Let's check it out. So which one's a base? You know bases have OH negative. OH negative. Hydroxide. So it's going to have OH negative. All right, that has an OH. That has an OH. That has an OH. You're like, oh my goodness, they all have OH negative in there. All right, so let's go to the reference table. Scroll back on up. Common bases. What makes a base a base? It has to be or has to have hydroxide. You have sodium hydroxide, potassium hydroxide, calcium hydroxide, or ammonia. Doesn't have hydroxide, but ammonia is a base. If we figure out common bases, you can figure out the correct answer is going to have to be with hydroxide, NaOH. NaOH, sodium hydroxide, looks like a solid answer. Let's go through, make sure it's not going to be any of the other ones, though. Check out choice C, HCl. You should be familiar with HCl. HCl is hydrochloric acid. HCl, common acids, hydrochloric acid. That's definitely an acid. Not the answer. We're looking for a base. Next one, choice B, CH3COOH is ethanoic acid. It looks like the OH is together there, but that's actually called a functional group. We'll talk about that next unit. And last one, there's an OH there, but notice these are nonmetals out front connected with an OH. A base is going to be a metal connected with an OH, a hydroxide. Choice A is going to be an organic compound with OH. That is actually going to be an alcohol attached to a carbon group, which we'll talk about next unit too. I don't expect you to really know that one. That was a tougher question. Alcohol is OH connected with an organic function. This is a different portion of the reference table, which you will go through next unit on that one too. You probably still could have got this. Common base, choice D for number 3. 3 is D. Let's try another one. Number 4. Try this one on your own. Question reads, red litmus will turn blue when placed in an aqueous solution of what? So try this one out. Think about the process. Think about, is this an acid or base? Which one's an acid or base? Please try it out. Put 1 minute on the clock. Give it a shot. Talk about it after 1 minute. What's this about? 101. Okay, please record your answer in the chat. What's your best answer for number 4? Red litmus will turn blue when placed in an aqueous solution of what? Please record your answer in the chat. Thanks, Irvin. Thanks, Jumila. Thanks, Nadina. Analyze. All right, here we go. Thank you for the responses. Still waiting for a few more. At home, if you're at home, please respond. Help me out here. You guys drive this class. Red litmus will turn blue when placed in an aqueous solution of what? All right, so I focused on litmus. Litmus is going to be red or blue. If it turns blue, the pH is going to be 8.3 to 14, somewhere in that window. So again, I think of this little pH scale right here. This says pH range. Think of this. This is a pH scale. Each one of these intervals is a pH scale. 0 to 4.5 is red. If it's 8.3 to 14, it's going to be blue. So think of a pH scale for any one of these, 0 to 14. Maybe you want to write those for the intervals. You don't have to, though. All right, we know the pH is going to be, the paper is turning blue. Blue. It's got to be 8.3 to 14. On the pH scale, next up, we have 8.3 and above. Is that an acid or a base? I'd ask you that question. Is that an acid or a base? Hopefully, no. It's going to be a base. Less than 7 would be an acid. So most likely, it's going to be a base. Let's see. Which one of these above is a base? Which one of the choices is a base? A lot of you guys put some answers. I have D's, A's, C's, different answers here. All right, so next up, I'd go through the reference table, find an acid, find a base. We're looking for a base. That's what we're trying to do here. Find a base. Check out the acid bases. Maybe you want to start off here. Base is going to have OH negative. Maybe you know OH negative. There's an OH. There's an OH. There's an OH. HCl, hydrochloric acid, is an acid. You can find that above. CH3, COOH, there it is. It's an acid. Ethanoic or acetic acid. So that OH is not OH negative. It is not paired up with metals. Can't be that. Just like the last question, number 3, CH3OH. That's an organic compound matched up with an alcohol, an OH. Choice D is going to be the best answer. I know we need to see more information on organic compounds like this and that. Choice D is the best answer. A metal with a hydroxide is a base. Metal with a hydroxide. Sodium hydroxide. That is your base. Common bases. Its range is going to go from 8.3 to 14. It's going to turn litmus blue. Best answer for number 4 would be choice D. 4 is D. Anybody have questions on how we got that? Please ask. Any questions? Anybody? All right, let's try another one. Number 5. It's got a table here. I don't think we need the chart at all. All right, so in this chart, it says indicator change pH range at which the change occurs. Brome thionyl blue is going to be yellow or blue. Thionyl blue is red or yellow. Methyl orange is red to yellow, red or yellow. The table shown was compiled from experimental laboratory data. At what pH would all 3 indicators appear as yellow? So there's an unknown solution, and this unknown solution was tested 3 different times with 3 different unknowns, and every time they all turned yellow. Use brome thionyl blue, it turned yellow. We know something about the pH. pH is going to be less than 6.2. So in this first test, the pH is less than 6.2. It's going to be 0 to 6.2. Turns yellow. It's going to be the range 0 to 6.2. Anything above 6.2, it's not going to turn yellow. It might turn blue. So if it's less than 6.2, it turns yellow. We could get rid of choice D because that is not less than 6.2. Next test, check out thionyl blue. Thionyl blue, what happened here? In thionyl blue, we turned yellow. Yellow. What's yellow? On this scale, anything greater than 2.8 is yellow. So 2.8 and above would be yellow. 2.8 to 14 on this scale, on this test, would be yellow. Best answer so far, in between 2.8 and 14. Anything less than 2.8, you could omit. If it's 1.9, it's going to be like orange because it's in betweener. That's in betweener. 1.9, it's in between. That would be like an orange color. Nope. Can't be 1.9. It's going to be yellow. It's not orange, it's yellow. Last one up. Let's check out the last value. Last test is methyl orange. We said it turns yellow. Yellow is going to be 4.4 and above. 4.4 to 14. It's going to be yellow. If it's less than 4.4, if it's 2.9, it's going to turn red. Best answer here is going to have to be choice C. 5, the best answer is C. Questions? Should be getting a little bit better at this. Hopefully you're not crying about it. It looks like a sad face. Trying to go for a confusion face there. Confused. All right, next up. A couple more questions. Let's try this one. Number 6. The resulting of a testing a colorless solution with 3 indicators are shown in the accompanying table. Which formula could be represented by the solution tested? Try this one out. Think about the reference table. Think about the indicators. What's the best answer for number 6? Please go through it. Give you a stopwatch. I'll give you a minute again. Please try it out. Once you have your answer, please record your answer. Please record your answer in the chat if you got an answer. I'm going to highlight a couple more things first. Please record your answer in the chat if you derived an answer, or when you do. Thank you. 1 for 1. Thanks, Irvin. That's good. All right. So a lot of people said A. If you responded with me, said A. They knew that choice A is a base because it has OH there. But before they did that, they looked at the indicators. They figured out the indicators I highlighted here. Hopefully you know what's going on by now. 9 to 14, it turned pink. Okay. 9 to 14, if it turns pink, it's going to be about the base. It's all about the base. We did the same thing for litmus test. 8.3 and above turns blue. Says it over here. That is a base as well. So then you have to figure out which one's a base in the responses. Hydroxide, hydrochloric acid, sugar, another form of sugar, glucose. No. Those are organic molecules. We'll talk about them later. There's no OH together. OH should be collected or connected together. Best answer for number 6 is choice A. 6 is A. Last question. Here we go. Number 7, both HNO3 and CH3COOH can be classified as what? Take a minute, think about the process, record your answer in the chat once you have a response. Think about it. Give it a shot. Please record your answer in the chat. Crisscross. Choice A. 6 was A. Please record your answer in the chat for number 7, please. Thanks, Alex. Thanks, Irvin. Leo, what did you get for 7? You get an answer or no? A. All right, thank you. You agree, Santino? All right, a lot of people are saying A. I have some B's for answers as well. Let's check it out. So I figured out HNO3. HNO3 was an acid. There it is. I highlighted it to the left on the reference table. I figured out CH3COOH was an acid, ethanoic acid. Cool. Those are definitely both acids. So those are both acids. I know that. I know acids on the pH scale go from 0 to 7. Those are acids. We use litmus tests. Down here, small font, I'm sure. 0 to 7, 0 to 4.5. That's pretty darn close to that range I have up here in my pH scale. That's going to be an acid. 0 to 4.5 is going to turn red. So red, litmus, it's going to turn red. It's going to turn red for sure. And they're both going to be arrhenius acids. 7, the best answer is choice D. 7 is D. Any questions on? Oh, 7 is A. Thank you. 7 is definitely A. A. There you go. D is definitely not a choice. Or there you go. So any questions on indicators for acid bases? 7 is A. Thank you. Let's watch another flick, and then I'll give you time to work on the exit pass. So here we go. Flick time, and I'll give you time to work on the exit pass. Huh? Time always flies in this class. Me too.
While it is possible to quantitatively measure the pH of a solution using a device known as a pH meter, there are also ways to determine pH qualitatively. In this lesson, we'll learn about indicators, which help us indicate the pH of a solution. An indicator changes color depending on the pH of the solution analyzed. Because of this, they are also known as pH indicators. Universal indicator is very versatile as it can measure pH across the entire scale from 0 to 14. It is not a single indicator, but rather a combination of various indicators. If you look at the color changes of universal indicator according to the pH of a solution, you will find that it resembles a rainbow. If universal indicator solution turns deep red in a solution, it means that the solution is strongly acidic, with a pH of 1 to 2. If the universal indicator solution turns green, it means that the solution is neutral with a pH of 7. If the universal indicator solution turns dark blue or purple, it means that the solution is strongly alkaline. Universal indicator paper works in exactly the same manner. Litmus is another indicator commonly found absorbed onto paper as litmus paper. Blue litmus paper turns red under acidic conditions, pH less than 7. Red litmus paper turns blue under alkaline conditions, pH greater than 7. Phenolphthalein is an indicator commonly used to determine the endpoint of a strong acid strong alkali or weak acid strong alkali titration. It goes from colorless to fuchsia pink at a pH of 8.2. Methyl orange is used to determine the endpoint of either a strong acid strong alkali or strong acid weak alkali titration. It is red at a pH lower than 3.1 and yellow at a pH higher than 4.4. In conclusion, indicators are substances that change color at a certain pH. The point at which an indicator changes color is known as its endpoint, which can be at any pH. Common indicators that you will encounter are universal indicator, litmus in the form of litmus paper, phenolphthalein, and methyl orange.
All right, there's a little bit more information on pH indicators. For now in class, I'm gonna give you like 13 minutes to work on the exit pass. So please open up your exit pass. pH indicators, topic 4B. Now you should be able to do the exit pass. This assignment will be due on Saturday. If you do not finish it or do not finish it in this time span of 12 minutes right now that I'm giving you in class, so at 12:45 we'll switch it up, then this will be due on Saturday. These questions should be really easy because some of these questions are exactly the same. If you paid attention to the examples, you should understand how to do these questions on the exit pass. So again, please join the breakout rooms, put you in a breakout room by yourself. If you have any questions, I will try to get to you and I'll try to address your questions. Please ask for help if you need help. Please join the breakout room. Please complete the exit pass on topic 4B, pH indicators. You have from now till 12:45. If you need help, ask for help. Please join the breakout rooms. or at home it worked out for you. All right, folks, another 30 seconds. Everybody will be back to the main session. Hopefully finish up the exit pass. Be right with you in 20 seconds. All right, again, please make sure you finish up the exit pass. If you did not finish it up right now, it is due by Saturday. That is definitely getting graded. Examples do not get graded. Exit passes do get graded. We are all done with topic 4B. There's like 20 minutes of class left, less than 20. We are done with topic 4B, pH indicators. We did that. I was talking to some students and they actually knew how to do this without even the lesson today. Yeah, I think you guys probably could have figured it out for this topic, but it's nice to have examples just to make sure you know what you're doing. Next up, here we go. Topic 5A. Next topic, 5A, is going to be on neutralization. I'm not going to play the video today. I'll play that next time. What we're going to do is just take some basic notes on what the heck neutralization is. So please open up your guided notes. Again, if you're in person, you can write on the hard copy or you could continue on Google Docs, whatever you prefer. So,
I did most of the notes online.
all right. You can just turn them both in. So wherever you left off before, just start there in the notes, all right? So if you have that, that's fine. All right, that's cool. Whatever you want to do. Either way, as long as I have them all together, that's fine. All right, so we already went through 3 theories for acid and bases. We talked about Arrhenius, we talked about Bronsted, we talked about Lewis. We talked about the pH scale, done. We talked about pH indicators, done. Next time, we'll actually start off with a demonstration where we'll use indicators to figure out what the pH level of unknown solutions are going to be. You can see my little rainbow here. It's working on the rainbow. The rainbow obviously is in the pH scale too. So when you're dealing with a solution, you want to know if it's going to be an acid or base so it doesn't harm you. So you touch it and it's not going to hurt you or give you a chemical burn. We talked about Arrhenius theories. We talked about acids being very sour. We talked about bases being bitter. We talked about Arrhenius being H plus or hydronium. We talked about common examples for acids. We talked about mono, di, and triprotic acids, 1, 2, and 3 different H's that can be ionized. We talked about an example for Arrhenius acids. We talked about Arrhenius base needing hydroxide. We talked about the example for Arrhenius base. We analyzed examples in the reference table for Arrhenius bases as well. We talked about a chart for Arrhenius acids, Arrhenius bases on page 3. Page 4, we talked about Bronsted-Lowry acid, Bronsted-Lowry bases. Acids are going to be H plus donors. Bases are H plus acceptors. We looked at a chemical reaction for Bronsted-Lowry. We figured out which 2 are most similar. We label those as conjugate acid-base pairs. We found the other similarities between the other parts of the reaction, and we said they're acid-base pairs as well. We also talked about conjugate acid, conjugate bases. They're not going to ask about that in the benchmark or the final. Benchmark or post-test. We talked about Bronsted-Lowry acid bases with a chart. We talked about Lewis with Lewis dot diagrams and electrons. So 3 different theories for acids and bases. Lewis is not as important as Bronsted and Arrhenius. So don't really focus in on Lewis. We talked about reactivities with metals, metals with acid. We saw how they reacted. Again, a little refresher, we said an acid like H2 with a metal. Metals react with the acid. Anything above it is going to react. Acid with sodium will react. Acid with magnesium will react. Anything above H2 will react with an acid. Anything below will not react with an acid. Copper, silver, gold. We talked about the reactivity, talked about indicators, just did. We spent like a whole class making this pH scale amazing. Hopefully you know about pH scale. Hopefully you can label the major components of a pH scale. Today, the rest of class today, we're focusing on neutralization. So neutralization, the topic for today's class, the rest of today's class. We'll analyze examples and the exit pass questions next time. But anyways, we're going to start copying some notes on neutralization. We'll wait for next class for titration. So neutralization, if you're neutralizing something, you probably think of maybe it stinks in like the bathroom after your brother went in the bathroom. And mom says, throw some neutralizer in there. Spray it with some Febreze, whatever. So if you're neutralizing something, you're mixing two things together. Like neutral solution, like water. Neutral solution is going to be like a 7 on the pH scale. How do you get to that neutral solution? You're taking an acid and you're mixing it with a base. So neutralization, here we go. Copy up the notes. Mine's on page 8. Yours could be different. I don't care where it is. Maybe your pH scale is a little bit bigger. I'm going to bold, I'm going to cap, I'm going to highlight. You know my drill. I'm going to blow this up too. Neutralization reaction. What's going to happen in a neutralization reaction? It's going to be an arrhenius acid reacts with an arrhenius base to produce salt and water. Really easy notes today. Neutralization reaction. First thing up, neutralization reaction. Cap block, color. A neutralization reaction is when an arrhenius acid like an H3O positive acid, H positive, or H so hydronium reacts neutralization reaction. You have an acid reacting with arrhenius base. Base we should know is OH negative by now. Base is going to be OH negative to produce salt plus water. You mix an acid with a base, what's going to happen? You're going to have a product of salt and water. What's a salt? Salt is going to be an ionic compound. Salt plus water. Neutralization reaction. Here we go. Consider the reaction between hydrochloric acid and sodium hydroxide. In the text box below, we're going to represent this reaction. So please click inside the text box. I'm not going to draw it up. I'm going to center it up, though. I'm going to make my font bigger. I'm not going to the drawing board. This reaction is going to be HCl, hydrochloric acids, HCl. HCl, we should be aware of, that is an acid. HCl aqueous plus the sodium hydroxide. You should be able to classify and organize what that is. Sodium hydroxide, Na, sodium. Hydroxide's OH. This is going to be aqueous as well. Hydrochloric acid plus sodium hydroxide yields, forward reaction, salt plus water, which this is going to be H2O's water, obviously. H2. You do not have to color code it the way I am. And salt, which is going to be NaCl. aqueous. All right, please take your time. Please make this chemical reaction for neutralization look similar. And what we should know, I'm gonna press enter below. What we should know is HCl is my acid plus the base yields salt plus water, or water plus salt. Either way, say base plus acid, acid plus base. You're adding them, so you can switch the order on that all the time. So water plus salt. Neutralization reaction. Acid plus base yields water plus salt. So another chemical reaction that we're analyzing. What reactions have we analyzed? We analyzed a synthesis reaction, taking two things to add them to one. We've analyzed a decomposition reaction. We take one thing, you break it off to two things or more. Single replacement we talked about, substitution, double replacement. We talked about redox reactions, oxidation and reduction. And the next reaction we're talking about is neutralization reaction. Acid plus a base yields salt plus water. Let's hammer out a couple more pieces of notes here. Really easy stuff. As a metal reacts with an acid. Metal reacts with an acid as a metal. Metal reacts with an acid. Hydrogen gas and a salt are formed. Hydrogen gas and a salt are formed. What's a salt in this class? Salt is going to be an ionic compound. Salt, told you, don't think of salt as the stuff on your fries anymore. A salt is going to be an ionic compound. KCl, NaCl. Salts are ionic compounds. We should know ionic compounds can be a metal and a non-metal. They transfer the electrons. It's a positive charge. It's a negative charge. It's a cation. It's an anion. Examples could be NaCl, like a binary compound, or it could be NH4 3PO4. That's a ternary compound. There's two polyatomic ions. The last portion of notes for today's class is complete this chemical reaction. Neutralization reaction. What is it? Acid plus base yields salt plus water. And next class, we'll definitely analyze some examples, some exit pass questions regarding that. I'm just going to copy this little text above. I'm going to copy it and paste it below. A neutralization reaction, an acid plus a base yields salt and water. Okay, guys, once you're done with that portion of notes today, that's going to be it for today's class. We'll analyze examples. We'll analyze exit pass question. We'll watch a flick on that tomorrow. I'll also do a demonstration on this, and then we'll get to titration too. That's it for today's class. If you have any questions, feel free to hang out. I'll see you guys later. Have a good day. Make good decisions. Stay safe. Bye, guys.